Okay, so Martine Visser is an associate professor within the School of Economics at UCT. She received her doctoral degree in economics from the University of Gothenburg in 2007, and she's on the executive committees for the Environmental Economics Policy Research Unit, the Research Unit for Behavioural Economics and Neuroeconomics, and the Research Associate of the South African Labour and Development Research Unit. I'll leave it to you, Martine.
Thank you very much. Okay, so I'm speaking to you today about economics of climate risk and behaviour, and focusing specifically on experimental evidence of small-scale farmers in the Western Cape. I'm Martine Visser. I did this work in collaboration with Kerry Brick and Ferry Guata. We're from the School of Economics. I'm also affiliated with the Environmental Economics Policy Research Unit and with the Research Unit for Behavioural and Neuroeconomics, all based within the School of Economics at UCT. To give you an overview of what I'll cover, I'll speak briefly about what behavioral economics is, then mention how we can use experimental methods to test behavioral theories. After that, I'll refine a little bit how we define risk and risk aversion before we move on to decision-making when facing climate risk. What we're really interested in is how risk aversion affects adoption of technology, especially among small-scale farmers and the poor, but also how lack of access to credit and insurance may act as barriers or constraints to the adoption of technology. And the case study that we'll be focusing on here specifically looks at small-scale farmers from the Western Cape in South Africa, where we used framed experiments. So behavioral economics really departs from traditional economics in that it expands the notion of traditional economics, in that it doesn't only assume that people are rational, self-interested income maximizers, but actually makes provision for the fact that people have social preferences and that may influence their decision-making. And this may include preferences like trust, cooperation, altruism, and also risk aversion. So what behavioral economics really attempts to do is to increase the explanatory power of economics. So it provides more realistic psychological foundations to economics. And so while it changed some of the underlying assumptions associated with economics, it doesn't completely reject the new classical approach, as Anton does. So most of behavioral economic theories use experimental methods to test behavioral theories. Typically what we do is we use monetary incentives and controlled environments to test to what extent individual behavior departs or conforms to economic or theoretical predictions. And the controlled environment is really useful in that it allows us to control the number of participants, the positions that they may hold, outcomes they may affect, information we provide, and also the potential payoffs. And so what's useful about that is that you then can actually test the effect of specific interventions on individual behavior, where in the real world you may have a lot of variation of variables going on and makes it difficult to pinpoint specific effects of interventions. So let's talk a little bit more about defining climate risk and risk aversion. When we think about risk, there's really two aspects that we need to consider. There's the part that deals with the chance that a bad event might occur, which really deals with probabilities. And then there's the consequences realized if a bad event does occur, where we're really thinking more about the magnitude of such consequences. And we also want to think about how people perceive risk, and Anton touched on that. In terms of, we need to, to understand that, we need to differentiate between objective risk, where we have specific outcomes to which we can attach objective probabilities, versus subjective risk, where we can imagine within a society we have a huge amount of variation with regards to how people perceive risk. Right? When it comes to modeling risk preferences, there's competing theories, which includes expected utility theory, prospect theory, rank-dependent utility theory, and economists are also increasingly using mixture modeling when they try to understand intertemporal behavior or behavioral types. Expected utility theory is probably traditionally the most popular model or the economic workhorse for modeling risk aversion. it assumes that individuals have concave utility functions, and what that means is that a risk-averse person would be reluctant to accept a bet with an uncertain payoff over another bet with a certain payoff but a possibly expected lower payoff. The prospect theory, as defined by Kahneman and Tversky, actually allows for useful extensions of these kind of modeling of risk aversion, because it assumes that people care more about losses than gains, which is quite appropriate within the climate change context, if you think about it. What it also does, it assumes that individuals consistently overestimate low probability events, like being attacked by a shark, whereas they consistently underestimate the likelihood of high probability events, like ending up in a traffic accident. There's a lot of different methods for eliciting individual risk preferences, and a popular technique that we've used quite often is the certainty equivalent method, where subjects make comparisons between risky prospects and sure amounts. So if you look at this example here, for instance, in option 1, you always face a sure choice, whereas option 2 is a risky prospect where you face either you can gain 0 Rand or 50 Rand, depending on whether the spinning wheel lands on black or white. And you can obviously use different probabilities when you present the wheel. So here we have a different representation of a lottery that people may face. This we used, for instance, when we were trying to get at mixture modeling. And here a subject would, for instance, face up to 60 different choices, each time having to make different choices between each or choose a different option. Sorry, there seems to be some problems with the print there. But basically, here, say, option 2 would be your sure bet of getting 100 Rand. And option 1 would be the risky prospect where you stand to gain 150 Rand, 100 Rand, or 0 Rand, with different probabilities attached to each of those. You can also frame that in a loss domain. Sorry. Here we go. So where the individual then stand to lose certain amounts of their money. It's also important to distinguish between risk and uncertainty, where with risk, the possible consequences of a decision can be completely enumerated, and the probability and specific probabilities can be assigned to each possible outcome. With frequent events, such as the incidence of death from smoking, it's possible to predict those probabilities with quite high accuracy. The problem with uncertainty, however, is that there's often no past form or baseline associated with it, and often the underlying properties of the phenomenon are not well understood, which makes it impossible to assign objective probabilities to the outcomes. And if you think about something like the melting of the polar ice caps, that's a very good example. Now, moving on to decision making when faced with climate risk, what we find is that the nature of climate risk involves increasing variability with regards to temperature, rainfall, evaporation, etc., which is associated with the greenhouse effect, as well as an increase in the likelihood of extreme events occurring, as we've seen in the last while in, for instance, the Eastern Cape. It's therefore quite likely that most individuals face a loss domain when faced with climate risk rather than a gains domain. And what we expect with all this uncertainty, that people might also be ambiguity averse, which is sort of an aversion to uncertainty, rather than only being risk averse, and that we might need to take that into account as well. Amongst the most vulnerable to climate change is obviously people working in agriculture and the poor. And we're specifically interested in small-scale farmers and also impoverished communities to see how they will respond to climate risk in the uptake of adaptive strategies like new farming technologies. What we've seen in the literature basically is that the slow uptake of technology amongst small-scale farmers in developing countries is one of the underlying factors for persistent rural poverty. And what many studies that link risk aversion and uptake of technology does is it assumes that these farmers have specific beliefs about the yield variance of new versus old technologies, and also that they have a quite good ability or understanding of the probability of having high and low rainfall. But with climate change, really, where people are facing increasing variability in rainfall, and it's becoming more and more difficult to predict that, we often find that small-scale farmers are quite uncertain as to the variance or distribution associated with yield outcomes of new technologies. It's quite possible that amount of uncertainty makes them reject new technologies outright from the start. And again, given the amount of uncertainty, probably wise to consider both risk aversion and ambiguity aversion as factors that might limit the uptake of technology. Besides for wanting to look at this link between risk aversion and technology uptake, we also want to consider what the effect is of lack of access to credit and micro insurance or insurance in general on the uptake of technology. So what we've done is, we've looked at 2 different districts where we worked with small-scale farmers in the Western Cape. In total, there was 125 small-scale farmers involved. Then in the Matsikama district, we worked with people from Van Rensdorp, Klaver, Ebenezer, and Lutzville. And in the Cedarburg district, we worked with small-scale farmers from Klein Willem and Wuppertal. Basically, we used 2 different treatments. In the first treatment, we just tested for risk preferences using the methods that I described earlier. And what we look at here is just a visual representation of those risk preferences across our sample, where you see a sort of bell-shaped distribution, where this is the most sort of risk-loving and that the most risk-averse participants, with most of them erring more on the side of risk aversion, which is quite normal. Moving on. In the second treatment, we used a framed experiment where individuals were then facing different farming seasons. Each round represented a different farming season, and we had 8 rounds. So they had to make decisions about what kind of seeds to plant. There were 3 options. Basically, the first one was to plant traditional seeds with a low variance and low yield. The second option was to purchase improved seeds, where the improved seeds were in fact costly and they had to take out a loan in order to do that, but with the potential of a high yield but high variance. And the third option gave them the potential to purchase the improved seeds with the loan, but to take up additional insurance, which would cover them in the instance of a disaster. In each round, the probability of rainfall there was associated a certain amount of risk with rainfall, which we represented by good rainfall, meaning was associated with 3 blue balls, low rainfall with 3 yellow balls, and very low rainfall with 3 red balls, which we all chucked into a plastic bag each round. We would draw a ball, and that would determine what the rainfall would be for that round. So if you look at option 1, where we had the traditional seeds with low yield and low variance, irrespective of what ball was drawn, and so whether it was low or high rainfall, they'd get more or less the same income in that round. For option 2, which involved the purchase of improved seeds with the loan, there you had the potential to have really high yield, but also high variance, which meant that if the red ball was drawn, you could really make negative earnings, whereas if the blue ball, the good rainfall ball, was drawn, you could have very high income from that round. Lastly, there was the option 3, which included the improved seeds with the option of taking out insurance, and there you still had the potential for quite a high yield, but now you were able to reduce your risk by taking out insurance, even though it was costly. If a disaster did occur, or you got very low rainfall, it meant that you were covered to an extent for that damage. So just looking at our results, what we found, this is the percentage uptake over 8 rounds. And what you can see by here for the traditional seeds is most of our samples started off purchasing traditional seeds. At that point, they had very little income. And as the game continues over rounds, you can see that the percentage of the sample who chose the traditional seeds diminished. Interestingly, even from the start, quite a high percentage of the small-scale farmers chose the second option, which was the improved seeds with the loan. And even though it fluctuates, it stays more or less the same over the different rounds, which shows that there is, in fact, an appetite for this kind of high-yielding, high-variance products, even though one might consider these people to be very risk-averse. And then, interestingly, the third option, the improved seeds, which involved the loan and insurance, started off from a base of about 0, and then over rounds, as people accumulated wealth and also experience in the game, increased. So what we're really seeing is that some of these people initially choosing traditional seeds, as they accumulate wealth, they actually prefer to switch to the option where they have higher yielding product, but where they're partly insured against the risk, which is quite interesting. So some of the determinants from our analysis that we found for the technology uptake and insurance were, in fact, risk preference as we measured it in our first treatment. Another factor was education levels amongst our sample. And then, interestingly, as I said, accumulated wealth over rounds, which is a good indicator that income constraints may, in fact, be a determinant in constraining the uptake of new technologies. And lastly, we also found that exposure to shocks, so having experienced a bad or very bad rainfall in previous rounds, when you perhaps took up the loan option and made huge losses, actually affected your subsequent choices. So people then perhaps switched back to traditional seeds or otherwise to the insurance options. So with regards to policy implications, the take-home message for us really is that we need to pay more attention and investigate the willingness to pay for insurance amongst these small-scale farmers. With we need to take more attention to that, because there really seems to be an effective demand for insurance for this risk and as a risk mitigating measure. What our results also suggest is, even though risk preferences may be responsible for people's choice of technology uptake, it seems very feasible that institutional deficiencies like the lack of access to credit and insurance, and also income constraints, may play an important role in determining the uptake of technology amongst resource-poor farmers. Thank you very much.
Okay, thank you very much, Martine.